Now, do we start, students? All have joined?
Yes,
Hello?
sir.
So you have all joined now?
Hello.
Should we start? Yes.
Yes, sir.
Yes. Good evening to all of you.
Yes, sir. Good afternoon, sir.
Good evening, sir.
Good evening, sir.
Good evening.
So today we'll, yes. Good evening, good evening, good evening. Somnath, Gitanjali, Mahadev, Rajasmita. So good evening to all of you.
Yes, sir. Good evening. Sir, I am from Kolkata, West Bengal.
Somnath, Kundu, Mahadev from which state? Somnath?
Sir, West Bengal. West Bengal, sir.
Mahadev, you
West
are
Bengal,
from which state,
Kolkata.
Mahadev?
West Bengal, sir.
Okay,
West
then
Bengal,
Somnath.
Kolkata.
Okay. Okay, anyway. West Bengal, West Bengal.
Sir, I am from Odisha.
Okay, okay. I know.
Sir, can you hear me? Okay.
Okay. Okay, okay. Okay. Rajasmita?
Sir, I am
Namaste.
from Odisha,
Namaste,
Baleshwar,
namaste.
sir. Yes, sir. Can you hear me?
Sir, I am from Odisha.
Oh, Baleshwar. Okay.
Sir, I am from Odisha,
Yes,
Puri.
I can hear you. So,
Sir, I
you are
am from Puri, Odisha.
Actually, I am from Baleshwar also.
No.
I am from Baleshwar. My native place is Baleshwar. Good. Somnath, you are from which state?
West Bengal.
West Bengal. Okay.
Yes, sir. Kolkata.
Okay. Good. Good.
Yes, sir. Namaskar.
Namaskar. Namaskar. Okay, we will start now. Today we'll do some the remaining thing of the block 2. That one we will discuss. Block 2 remaining thing we will discuss today. Then we'll go to block 4, 3. No, today we'll start block 3. Block 3. Block 3, unit 6. Okay. Unit 6 is kinetic. Unit 6. Block 3, unit 6. Who is calling, please? Please mute your microphone. Okay. Unit 6 we'll discuss. Okay. Unit 6 is your kinetic methods of analysis. That one we'll discuss today. And in this chapter, we are going to discuss about the introduction, objectives, types of chemical methods, measurement of reaction rate, then catalytic mathematical model of kinetics. We will also discuss about the catalytic method, enzymatic and non-enzymatic. Also, we will discuss about the instrumentation, applications, and all these things. So first of all, or moving towards the introduction part of kinetic methods. What do you mean by kinetics? If you ask me that what is kinetics, then I can say it is nothing but the rate of reaction. For example, you know in physics, there is a word called kinematics. In physics, it is called kinematics, and in chemistry, it is called kinetics. It means the measurement of rate of reaction or the study of rate of reaction. So first of all, we'll go one by. Whenever we are discussing about kinetics, means we are discussing about how fast a chemical reaction takes place or how slow a chemical reaction takes place. As you know, chemical reactions are three types. Chemical reactions may be fast, chemical reactions may be slow, or chemical reactions may be moderate. So basing on this, fast, slow, or moderate, we are deciding the kinetics of a chemical reaction. So now I will tell you that there are different types of chemical reactions are there, basing on which the kinetics also vary. For example, as you know, many chemical reactions are catalyzed by chemicals. Without any chemicals, you cannot, without a catalyst, the reactions may not take place. Many reactions are accompanied by use of catalyst. For example, as I am telling you, a non-enzymatic means without having any enzyme. And then the reaction may be redox, maybe chemilutionants or complexations. And in case of enzymatic, it may be homogeneous or heterogeneous. So, basing on this, we'll discuss one by one. First of all, we are discussing about the kinetics measurement. First is called as the mixing methods. Mixing method means what? Methods based on mixing and following of reaction course during different equilibrium states. What do you mean by mixing? Mixing means it may be batch mixing, stopped flow mixing, or continuous flow mixing. Remember, this is the method we are using when we are measuring the rate of a chemical reaction. Then there are relaxation methods are there. We are using jump technique, periodic relaxation technique, and spectral relaxation technique. I am not going in details to these methods because this is not so much important for you. What is important is the study of the chemical reactions or measurement of a chemical reaction. So first of all, I will discuss very important thing, as you know from +2 classes also, what is called a rate. Rate means change in concentration by time. For example, you are doing a chemical reaction, then reactants you have taken having initial concentration something, for example, equal to A, and then after some time, the concentration changes to B, then you can say there's a change in concentration from A to B. When there's a change in concentration from A to B, then change in concentration by how much time taken to change this concentration. If you divide, then you calculate the rate. The rate of a reaction is nothing but change in concentration by change in time. And remember, the rate of a forward reaction and rate of a backward reaction. Remember, when we are considering a rate of forward reaction means what? If there is an equilibrium reaction, then there will be a rate of forward, it will be backward reaction. Otherwise, always remember that when the reaction occurs, then the concentration of reactant decreases and concentration of product increases. So in the graph 6.1, if you have the book or PDF, then you can see there the graph figure 6.1 is the first figure in this unit, represents concentration versus time graph. And here you will see that the reactant concentration is continuously decreasing, and at last it touches the x-axis means 0, and the concentration of product continuously increasing from 0. So reactant is concentration is decreasing and product concentration is increasing. This is the simple rate of a chemical reaction. So in a particular chemical reaction, the concentration of reactant will decrease and that of the product will increase. These things, you remember it. Then we go to different methods to plot this concentration versus time graph or product versus time graph. There are 6.2 figure relates the product versus time graph, means a different time interval, how much of products are obtained is drawn in the form of a graph called initial rate method. So how much is the initial, and after time t or after some time, how much initial concentration is decreased and how much the concentration of product will increase. This can be plotted in the graph you can see in 6.2. So see, in this differential method or the method based on this concentration versus time graph, we are mainly dealing with the how fast a chemical reaction takes place. Then at particular interval of time, you can know that how much a product is obtained. For example, you have I think you have heard in +2 average rate, instantaneous rate. Average rate means you started from a point and end at a point. Then in between, you may have moved with different speed. Then it is called as average. Average means each instant you have a rate, but after some time, you find a particular rate. It is called as average rate. So average rate and instantaneous rate can be expressed in terms of equation del x by del t or dx by dt. Del x by del t means a change in concentration by change in time, but here del x represents a bigger change. But if it is dx by dt, which is called instantaneous rate, it is very instant. When for a particular position, if you want to know the rate, then you have to do it by dx by dt method. Okay. Next one is I'm discussing about the integration method. Here, integration method means, as I've told you, differential method. You are taking a product concentration in the y-axis and time in along the x-axis. But now what you do, you take time along x-axis, but a logarithm of product along the y-axis. This is called the integration method. Integration method means taking log of it, log of product. Or also you can take log of initial concentration, log of A0. If A0 is your initial concentration, then you can write log of A0 minus P. Minus P means product. This equal to your log P. So log P means log A minus P. So this is plotted against the time. Then you get a straight line graph, which is curved line graph in case of differential method. In integration method, you get the straight line graph. Students, I am discussing about different methods to calculate the rate of a chemical reaction, because whenever you are doing some reaction in a lab, then you have to measure the rate of reaction. That means how fast a reaction takes place. Therefore, I'm telling you that you have to measure the del x by del t or dx by dt. Then next one is induction period method. Induction period method means here, for example, A plus B gives you a product P and the reaction is slow. Then P plus L is a catalyst. P plus L becomes a fast reaction to give you Y. So remember that according to Landau effect, the reaction which is slow, its rate is to be determined. For example, there are two reactions are there. Two steps are there. In first step, it is a slow step, and second step is a fast step. Then remember that whenever you are measuring the rate of a reaction, the slowest step its rate is to be calculated. If a reaction is fast, then its rate is not calculated. So slowest step of a reaction, the rate can be determined. It is you have to remember, the rate can be determined only when the reaction is slow. Only when the reaction is slow, then only you can determine the rate of a chemical reaction. You can only measure the reaction when the reaction is slow. So in different cases, the rate of reaction varies. The next one is your linear extrapolation method. This is also a graphical method in which exponential graph will be taken. Here, the PT is plotted against a function of exponential of minus KT. K is your rate constant. K is your rate constant. These are all experimental things. You can only by drawing graph, because the values you get from the instrument itself. Remember, all the values are obtained from the instruments. Nowadays, instruments are so improved, so modern, that you can easily know the value of it. But thing is that you have to plot it in a graphical manner so as to know the result, or to know the rate of a reaction. The next one is a non-catalytic reaction. For example, a reaction is taken place without having any catalyst. Then the reaction may be very slow, because without a catalyst, the activation energy is low, and if the activation energy is low, then the reaction may not occur at all, or if it will occur also, it is a very slow reaction. But very slow reaction is very difficult to measure. Therefore, you have to add catalyst. Catalyst simply decreases the activation energy and increases the rate of a reaction. Factor influencing the rate. There are many factors which influence the rate. One is, temperature. Temperature is very important. With increase in temperature by 10 degrees Celsius, the rate of reaction doubles. If you increase the temperature by 10 degrees Celsius, the rate of reaction doubles. Therefore, rate of reaction is directly proportional to temperature. Then also, it is depending on the reactant concentration. The reactants you have taken, if its concentration you are changing, then rate of reaction also changes. The next what? Change in the solvent. During a chemical reaction, definitely we are using some solvent. So that solvent medium is also important to decide whether the reaction takes place faster or slower. So all these things you have to remember. One is temperature. Second one is the change in concentration of reactant. Third one is the change in the solvent medium, and all these things. Next is, we are going to mathematical derivation of rate law for first order reaction. Remember, this is a +2 syllabus course. You know it in +2 how to calculate the rate of a reaction for first order. Remember, first order means whenever you are writing the rate expression, then you must have an initial concentration. Initial concentration to the power 1, for example, 1 is called first order. So concentration to the power, some power will be there. That power is your order. If power is 2, it is called second order. If power is 3, it is called third order. If power is 4, sorry, if power is 4, yes, if power is 4, you cannot say it is fourth order, because the order does not exceed 3. The order does not exceed 3. The molecularity also does not exceed 3. It may be a complex reaction. So order may be 0, maybe 1, maybe fraction 1.5, but order does not exceed 3. So now we are going to discuss about the rate of first order reaction. For example, rate of reaction is directly proportional to change in concentration of the reactant. So the rate of first order reaction can be expressed as dA by A equal to minus K dt. This is the initial expression to write the rate of reaction which is in first order. So dA by dt, so dA by A is equal to minus K dt. dA by A is equal to minus K dt. So now what you do? dA by A, you integrate it. Integration takes place from initial concentration A0 to final concentration AT. So integration A0 to AT, dA by dt is equal to minus K integration 0 to T dt. So integration A0 to AT, dA by A is equal to minus K integration 0 to T dt. So when you integrate this, you get ln value. Ln AT by A0. Simple is the integration. I think you know it. dx by x integration is ln x. Integration of dx by x is equal to ln x. Similarly, it is ln AT by A0 equal to minus KT. Then AT by A0 equal to e to the power minus KT. As you know, when ln is removed, when we remove ln, then you have to write the exponential e. So e to the power minus kt. So ln, if removed from left side, then the right side value will be the power of e to the power minus et. This is the exponential expression of the first order rate of reaction. So then you can put the value of, then you can write like this, at is equal to A0 minus PT. Then PT is equal to how much? A0 into 1 minus e to the power minus KT. Simple, by putting the values in the equation, you get a is equal to E0, A0 e to the minus K by K is equal to A0. So when you say AT is equal to A0, then it is called as the time interval. Then we can call AT2 equal to 1 by e to the power 1 to A0. This is simply a derivation of the order of reaction, but main expression is K is equal to 2.303 by T log A by A minus X, where K is the rate constant, T is the temperature, A is the initial concentration, and A minus X is the concentration at time T. This is called rate of the reaction of a first order reaction. And for first order reaction, if you draw a graph, A it will just like a curve, parabolic curve. Rate law for second order reaction. Then similar thing, second order means there may be two reactants or one reactant which is of same concentration. When A plus A or 2A, you can write 2A is equal to product, or you can write A plus B is equal to product. So when you derive this, then it will be minus dA by dt is equal to K into A the concentration into R the concentration. Here A and R are the two reactants. A and R are the two reactants. Then minus dA by dt is equal to K A concentration into B concentration. Then you can write minus dA by A dt is equal to K dash A. Why A? Because why the R? If the composition of R it changes very little, means when two reactants are there, one may change very, one reactant may change rapidly, but the other one is very slow change or do not change at all. Its concentration you take as fixed. In that case, the a reaction becomes called as the pseudo fast order reaction. Pseudo fast order reaction. So students, a table has been given 6.3. Here you can see different order of reaction and their expressions are written in this table. Then next we will discuss catalyzed reactions. Catalyzed reaction means a reaction which is catalyzed by an enzyme. Remember, enzymes are very high molecular weight molecules and extremely used an analytical reagent because of their high degree of selectivity to specific species with which very they combine when acting as a catalyst. Remember, catalyst means, remember students, catalyst means it may be an enzyme also. You know, in many biological reactions in our body is catalyzed by enzymes. Enzymes are good catalysts because they have high degree of selectivity. That means they react with a particular compound and increases increases the rate of reaction. The rate of reaction can be increased by using this. Okay. So are you all listening? Yes or no?
Yes, sir. Let's.
Yes, sir.
So rate of reaction or fast. See, you read also your plus two books. They are also written the rate of first order reaction, rate of second order reaction, third order reaction. But first order is very important. Others are not so much important. But remember, whenever you are using catalyst or enzyme, then enzymes are good catalyst because they increases the rate of reaction by decreasing the activation energy. So when activation energy of a reaction decreases, the rate of reaction increases. This is a very important thing, you remember it. So for example, the enzyme is E, the substrate is S. Enzyme is E, substrate is S. Then you can get an intermediate ES, and the reaction may be having rate constant K. Then you can say that, 1 minute. ES. Then ES again gives rise to a product. And so enzyme will not attach to reactants. It simply enhances the chemical reaction. Enzyme का काम ये है कि वो reaction को faster करेगा. It will not participate in the reaction. It will not remain in the reaction. Once the reaction is over, the enzyme goes out from the system. But it passes through two steps. One is called intermediate state, or you can call also the activated complex state. Means ES. ES is the activated complex. After ES, you get the product and the E. So you can have see that they are the different rate constants are there. These rate constants, if you study, you can able to know that enzyme is a catalyst which increases the rate of a chemical reaction, and without enzyme the reaction may be slow, but with enzyme the reaction must be fast. Okay, then mathematical things are there. I'm not going by this way. You read as your own. Okay. Then we go to the one minute instrumentations. If you have book, then you can see that instrumentation for study of kinetic model is very important because there is a you can see one example of it. System diagram of a stopped flow technique. Different techniques are there. Their graphs are also given to you. and just read these things. It is not possible to explain in online mode how this experiment took place. But remember that the question will become, what is a first order reaction? What is a second order reaction? Remember, first order reaction means the reaction in which the rate is directly proportional to first power of the concentration of reactant, means A to the power 1. If it is A to the power 2 or A to the power 1 and B to the power 1, then 1 plus 1 is equal to 2. Sum of the powers of the reactants raised to their coefficient is called as the order of a chemical reaction. So order of a chemical reaction, it's simply it is measured in terms of the power of the reaction. So for example, if I will say H2 plus I2 2HI, then dx by dt is equal to K into H2 concentration to the power 1 into I2 concentration to the power 1. And 1 plus 1 is equal to 2. So I can say H2 plus I2 reversible sign 2HI is a second order reaction because 1 plus 1 is equal to 2. Similarly, if it is A to the power 1 or B to the power 1, then it is called as the rate is equal to first order. If A to the power 1, B to the power half, then 1.5, order is equal to 1.5. Depending the sum of the powers present in the rate expression above the reactant is called as its order of reaction. Then a question will come, for example, A plus 2B is equal to product. A plus 2B is equal to product. What is the order of reaction? Remember, A plus 2B is equal to product. By looking into this, you cannot say it is third order. But if the dx by dt is equal to A to the power 1, B to the power 2, then you can say 2 plus 1 is equal to 3. So it is third order. But with respect to A, it is first order. With respect to B, it is second order. Then if, for example, I will say, if the rate of reaction, if the concentration is half, then how it affects the rate of reaction? So you have to put the formula, then only you can. But and again, one more thing, remember also, that the zero order reaction is there also. Zero order in your course it is not written, but zero order is there also. Zero order reaction means in the rate of reaction in which the concentration of reactant to the power 0 means independent of concentration. Independent of concentration is zero order reaction. Then question also will come, what is the unit of first order reaction? The unit of first order reaction is rate constant of unit of rate constant of first order reaction. It is nothing but your what? K second inverse. Second inverse is the unit of rate constant for the first order reaction. Question will definitely come, what is the unit of rate constant for first order reaction? It is second inverse. But if I will ask you, what is the unit of second order reaction? It will be mole inverse, second inverse. Mole, moles per liter, mole in moles per liter and second inverse. Means mole inverse, liter, second inverse. Okay, that's all about your this unit 6, first one. Then we'll go to the second unit 7. In unit 7, you have acid base equilibrium. Acid base equilibrium. Acid base equilibrium means here our objective is to explain the acidic and basic properties of substances. Also, our aim is to calculate the hydronium ion concentration of diprotic acids and polyprotic acids, and also describe the ionization equilibrium of weak electrolytes. So first of all, acid-base concept we discuss. You know, in plus 2 also, there are three theories. One is Arrhenius theory, one is Bronsted-Lowry theory, and third one is Lewis theory. Lewis theory. One is Arrhenius theory, one is Bronsted-Lowry theory, and third one is Lewis theory. We'll discuss this acid-base concept very soon, but after a break of 2 minutes. So can I take a break, students?
Yes,
Then
sir.
we'll discuss about acid-base theory, Arrhenius theory, Lewis theory, and Bronsted-Lowry theory. These three theories are there in your plus 2 classes. We'll discuss its fundamental concepts of acid-base theory. Okay, 2 minutes break. Okay. Should we continue, students? Should we continue?
Yes, sir.
Okay.
Yes, sir.
One is Arrhenius theory.
Yes, sir.
I think you know Arrhenius theory. I think you know that whenever any substance you dissolve in water or and it will produce you H plus ion, it is called acid. If it produces OH minus ion, then it is called base. For example, if you add hydrochloric acid in water, it forms H3O plus ion, means water is there, H2O, and H plus becomes H3O plus. So any substance when you add to water, if it is producing H plus ion or H3O plus ion, it is called an acid. And if you get OH minus ion, it is called as a base. So NaOH is a base, but HCl is an acid. So HCl acid, but NaOH is base. Why it is NaOH is a base? Because NaOH gives you OH minus ion, but HCl gives you H plus ion. Similarly, acetic acid CH3COOH, though it is a weak acid, it also gives you H plus ion on dissolving in water. So acetic acid is also an acid. So anything which gives you H plus ion is an acid. Anything which gives you OH minus ion in water is a base. This theory is called Arrhenius theory. Now you understood, students? The Arrhenius theory means a theory in which an acid is a substance which on dissolution in water produces H plus ion, and base is a substance which gives you OH minus ion. So examples I've told you, one is hydrochloric acid, one is acetic acid, other one is sodium hydroxide, potassium hydroxide, calcium hydroxide, nitric acid, sulfuric acid, phosphoric acid, carbonic acid. All are producing H plus ion or OH minus ion. But remember, students, all compounds do not contain H plus or OH minus, but they are also acid and bases. Then how will you know that which are acids having no H plus ion or not producing H plus ion? Then this is a problem. Therefore, the new theory has come called Bronsted-Lowry theory. Bronsted-Lowry theory. So Bronsted-Lowry theory is basing on a donation of proton or acceptation of a proton. For example, any substance which donate a proton is called as an acid. If a substance accepts a proton, it is called as a base. For example, so we can call it as a conjugate base or conjugate acid. For example, if I will say Cl minus, it takes plus H plus ion to give you HCl. So Cl minus is a base because it okay and once Cl minus added to H plus, it gives you HCl. So HCl is an acid. So if HCl is an acid, then Cl minus is called its conjugate base. Why conjugate base? Because from HCl, if you are removing H plus ion, then you get Cl minus ion. So conjugate base means from the acid, if you are removing H plus ion, then it gives you conjugate base. So remember, students, conjugate base means removal of H plus ion. Similarly, conjugate acid means addition of H plus ion. For example, Cl minus is given. Question is asked, what is the conjugate acid of Cl minus? So what you will do? You add H plus. So Cl minus plus H plus is your HCl. So remember, students, same thing, but two different ways. Addition of H plus or subtraction of H plus. Subtraction of H plus from a compound will give you conjugate base, and addition of H plus gives you conjugate acid. So conjugate acid, if you get, you get only when you subtract, you add H plus. Conjugate base you get only when you subtract H plus. Subtraction of H plus, conjugate base. addition of H plus conjugate acid. A for addition, B for subtraction. So H, but it is only H plus, means proton. Therefore, Lowry-Bronsted theory or Bronsted-Lowry theory is based on the principle of addition of a proton or subtraction of a proton. Remember it. Addition of a proton or subtraction of a proton. Subtraction of a proton gives you conjugate base. Addition of a proton gives you conjugate acid. Students, have you understood this concept?
Yes, sir.
Who is talking? Who is talking? Tell your name.
Rajasmita, sir.
Radhaspita. So whenever a question will come that OH minus write its conjugate acid, then what you do? OH minus its conjugate acid. What you do? You add H plus. Yes, very good. You add. Who is talking?
Rohini, sir.
Rohini. Very good. Very good. You are listening. Add H plus. So OH minus plus H plus gives you water. So it is the conjugate acid of OH minus. Very good. If you are, for example, I will tell you CH3COOH means acetic acid. What is its conjugate base? Then simply you subtract H plus. Then it gives you CH3COO minus. It is the conjugate base. Okay, good. So many questions are given here. It is also called conjugate acid base theory. Means there will be two reactions like CH3COOH plus water gives rise to CH3COO minus plus H3O plus. So in this reaction, CH3COO minus CH3COOH loses a proton, but water gains a proton. So water gains a proton means water is the means it is the conjugate acid is H3O plus, and CH3COH loses proton means CH3COO minus is a conjugate base. Many examples are there in the book. You can refer to know which one is conjugate acid, which one is conjugate base. Simple concept. Addition of H plus conjugate acid, subtraction of H plus conjugate base. Next is Lewis theory. Next is Lewis theory. Lewis theory is based on electronic theory. Means acid is the substance that can accept a pair of electrons. Acid means it can accept a pair of electrons. Base means it can donate a pair of electrons. So acid means accept a pair of electrons and base means donate a pair of electrons. First of all, you remember the definition. Then only you can do other things. Okay. So Lewis acid means a substance which can accept a pair of electrons. Lewis base means a substance which can donate a pair of electrons. Now I will tell you some examples to explain how can you say that the compound is Lewis acid or Lewis base. For example, ammonia, NH3. In NH3, nitrogen atom has a lone pair because the nitrogen has formed 3 bond pair with 3 hydrogen and 1 lone pair remains as it is. Thus, ammonia contains a lone pair. Hence, ammonia can donate this lone pair to any other substance which requires it. Hence, ammonia is a Lewis base. So remember, students, ammonia is a Lewis base because in ammonia, nitrogen atom has a lone pair. Lone pair, if you do not know what is a lone pair, then I can say, okay, who can say what is a lone pair? Open to all. Who can say what is a lone pair?
Pair of two electrons that are not bonded with the other.
Yes,
atom.
yes,
Well,
yes. Please tell clearly.
hello.
Please tell clearly.
Sir, it is a pair of two electrons that are not bonded to any other atom. It's like in
So in
ammonia,
so,
there are three hydrogen atoms. So there will be one lone pair remaining in nitrogen. All other
right,
all other atoms, the electrons will be bonded to each of the hydrogen atom.
right. Can you say water? Then in water, oxygen has how many lone pairs?
Sir, two.
Yes.
Hello. So it will be
Tell
having
me.
two.
Very good. Two lone pairs. So ammonia, water, or amines. Amines also are NH2 is called primary amine. R2NH is called secondary amine. R3N is called tertiary amine. All these are Lewis bases because they can donate this lone pair to any other substance which requires it. Means to an acid. To an acid. Therefore, remember, students, there will be an acid-base reaction. So Lewis acid, Lewis base reaction means a Lewis base having an excess electron pair called lone pair is donated to a Lewis acid which requires a pair of electron. Hence, a bond is formed. This bond is called coordinate covalent bond. Coordinate covalent bond is formed between Lewis base and Lewis acid. So Lewis acids are normally, I can give example, BF3 boron trifluoride, SO3 sulfur trioxide, FeCl3, FeBr3, AlCl3, SO2. These are all examples of what? Here, Lewis acids because they don't have any electron pair in their valency cell. Again, they have deficient of electron to become octet. Hence, they can accept a pair of electron from the molecules having lone pair or a negative charge. Thus, it is called as Lewis acid. So, Lewis acid are AlCl3, BF3, BCl3, SOCl2, SO2, SO3, like this. They are all Lewis acids. So you can search the book here. There you can find out many chemical reactions and you can identify which are Lewis acids, which are Bronsted acids, and which are the Arrhenius acids. Then we'll go to one more thing that is called, because time is not in our hands, so you have to read many things. So therefore, I'm just, these are easy. I can skip it. You can read yourself also. And many one problem in online class is that we have many expressions to derive. So it is not possible to derive an expression. Very difficult to derive an expression in online mode. Okay. Then we go to a new thing. That is the theory of acid and bases. Next we go to buffer solution. So any idea about buffer solution, students? You know it? Buffer solution.
Buffer solution means to resist change in properties.
To resist change in which properties?
I think in case of soil science, we prepare buffer solution for standard for pH 7, yeah, 4 or 9.18. It is the buffer solutions for standardization of pH meter. In that case, this is a buffer solution to long time stable properties do not change.
Okay, that means you are telling that buffer solution means the solution which does not change its pH value. Yes, appreciably. Means pH value will not change appreciably. That type of
Ha,
solution you are preparing. Yes.
yes, sir.
Yes, because addition of an acid or addition of a base or alkali may change its H plus ion concentration or OH minus concentration. But buffer solution is such a solution. If you are adding a few drops of acid or alkali or any water also, it will not change in H plus or OH minus concentration. Hence, pH remains as it is. This solution is called buffer solution. See, buffer concept of buffer is used in many purposes during soil testing, during preparation of medicine. We are using buffer. Buffer is very important term because in many chemical reactions, you have to maintain the buffer capacity so as to carry out a reaction. Otherwise, in the meantime, when you are doing a reaction, there may be acid or bases. So the pH will change. Once the pH will change, the desired product cannot be obtained. So in order to get desired product, you have to fix the pH. That is by using a buffer solution. Okay, good, very good answer. So our aim is to here calculate pH of buffer. So pH of buffer means okay, you prepare a buffer. Buffers may be weak acid and salt of its strong base, or strong acid and salt of its weak base. So two types of cases you get it here. That is, one is called weak acid and salt of its strong base, or strong acid, salt of its weak base. Anyway, my question is how to calculate buffer pH. It is done by using a Henderson equation. I think you know in plus 2, Henderson equation. Henderson equation is basically the equation to measure the pH of buffer, basically used to measure the pH of buffer. It is not, I think, written here. 1 minute. Buffer. Sorry. Sorry, can I take 1 minute break and take some water? Right. So pH of a buffer is measured by using Henderson equation, and it is done by using a relation. This is not there in the book, not written also. So okay, we can or simply call pH, or yes, it is there. pH equal to pKa plus log Cb by Ca. Cb by Ca means conjugate base conjugate acid, or you can say concentration of base and concentration of acid. pK is called the negative logarithm of K. K is called dissociation constant, or also called ionization constant. So pKa plus log Cb by Ca, that is equal to pH, is called Henderson equation. Okay, how the vapor solution regists its pH? It is mentioned here that by how the addition of small amount of acid or small amount of base does not change its concentration appreciably. This is the reason why the vapor solution can resist to its pH. It is explained here by taking an example. This is not going into details. Okay, one more thing, effect of dilution. For example, any vapor solution, okay, a vapor solution, I've told you, remember blood is also an example of a vapor solution. Our blood is also an example of a vapor solution, because blood contains many things. Many things a blood can hold. Therefore, it is also called vapor solution. But main question is here, if you dilute a solution, then what will be the effect of pH? The pH of a vapor solution remains practically constant on dilution. Means there is a main effect. If you dilute the solution also, its pH will not change. If you dilute the solution, its pH will not change. Why not changing? Because no appreciable change in the H plus or OH minus concentration. Then one more thing is called buffer capacity. What do you mean by this? It is the number of moles of a strong base or strong acid which is required to change the pH of 1 liter solution by 1 pH unit. Very interesting. For example, you have a buffer solution. You want to calculate the buffer capacity. What you will do, it defined as that you add a strong base or strong acid. And how much you add, it depends on your number of moles. So number of moles of strong acid or strong base added to change the pH of 1 liter solution by 1. For example, consider a solution whose pH is 5 and you want to make it pH 6. So to make it 6, you have to add acid or base. You know what you will add, acid or base. As you know very well, acid, if you add H plus ion, the concentration will must be OH minus ion, it will neutralize. So anyway, by adding requisite moles of acid or alkali to change the pH of 1 liter solution by 1, means if pH is 5, it becomes 6. pH is 5, it becomes 6. Then how much you have added? This is called as the buffer capacity. Its symbol is beta. Buffer capacity generally varies with composition. So you have to go the with also the equation written in the book. The buffer capacity is nothing but the requirement of strong acid or strong base in moles to change the pH of a solution by 1 or by unity. Unity means 1. This is called as buffer capacity. So buffer capacity is clear, students?
Yes, sir.
What is this one? Who can say? Hello?
Hello.
Anyone responding? The amount of number of moles of acid or base you are adding to change the pH of a solution by 1 is called as buffer capacity. Yes, now?
Yes, sir.
Yes, sir.
Okay, very good. Very. Please, sometimes you should respond, because respond means I know that okay, you are listening to me or something we are going to discuss. That is the important thing. Yes or no? Tell me. See,
Yes, sir.
my chapters are slightly difficult. I don't know other chapters, other units, how they have taught. I do not know, but my chapters are slightly analytical based, experimental based. So it requires thorough reading. But time is less. We have to complete in one day, one class, one unit in one class, or 2 or 3 units in one class. Therefore, not touching every point of your unit. Okay. Next, we will go to see, problem will come also. Many problems will come. Problems will come. What is acid? Acid will be given. You have to write conjugate base. Base will be given. You have to write conjugate acid. Or Henderson equation, you have to calculate pH. I told you pH equal to pKa plus log Cb by Ca. Cb is concentration of base. Ca is concentration of acid. Like this. You can see your last called terminal, or this terminal questions. That one is very important. These terminal questions will help you how the question is coming. From there, the question has come normally. So then we'll go to unit 8. Is neutralization titrations. It is based on titration. As you know that in a titration, you need a burette, you need a pipette, you need a standard solution, and also you need the end indicator. So as I'm discussing this chapter called neutralization titration 1, neutralization titration 1. Okay. So so remember, during a neutralization titration, I think in +2 you have done it, acid-base titration. You always, I think you have taken acid in the burette and base or alkali in the conical flask through a pipette. Normally 10 ml pipette is used. You have added an indicator to it and then titrating, and to get the end point, I mean the point where neutralization takes place. So neutralization itself means acid plus base to give you salt plus water is commonly called neutralization reactions. And remember, if you are using weak base as standard base, then it is called alkalimetry. Alkalimetry. So why you are studying this acid-base titration or neutralization reaction? Because it will helpful to know or explain the concept of titrimetry, explain the nature of neutralization reacts titration curve, understand primary and secondary standards, describe the theory of indicators, select the appropriate indicators for a particular data titration. So these are some of the benefits, and also it is to have the pH. Okay, titration curves are there. Titration curves are plotted in the graph. You can see the table also, figure 8.1. These are called titration curves. Titration curves will tell you about the pH of a particular point, about the concentration of acid and concentration of base. All these things, pH, concentration of acid, concentration of base, all are there in the graph of pH metric. pH titration curve for weak acid and strong base. Weak acid is CH3COH, strong base is NaOH. So if you want to draw the graph between weak acid and strong base, first of all, I said say you that pH is nothing but pKa plus log salt concentration by acid concentration. This is a formula you have to remember that pH equal to pKa plus log salt concentration by acid concentration. Salt concentration by acid concentration is the pH. Similarly, okay, if you derive this equation, pH equal to pKa plus log salt by acid, it will be pH equal to 7 plus 1 by 2 pKa minus 1 by 2 Pc. 7 plus 1 by 2 pKa minus 1 by 2 Pc. Then next is your weak base and strong acid. Weak base means ammonium hydroxide, weak base. Strong acid means hydrochloric acid. There will be a reaction between weak base and strong acid. And for that, the pH will be pH equal to pKw minus pKb plus log base by salt. Again, I will say, if it is weak base and strong acid, then I'm not going the derivation in details. Directly, I am telling about the equation. And this equation is important to do the problems. So pH is equal to pKw minus pKb plus log base concentration by salt concentration. Base concentration by salt concentration is your pH. Similarly, if it is weak acid and weak base. So first of all, I have discussed strong base, weak acid. Then I have told you weak base and strong acid. Now it is weak acid versus weak base. And in this case, pH equal to, in this base, pH equal to your half of pKw plus half of pKa minus half of pKb. The formula pH equal to half of pKw, half of pKa minus half of pKb. Okay. Next is theory of indicators. As you know, we are using indicator to know the end point. Whenever you are doing an acid-base titration without end point, you can able to observe its changes. For example, as you know, acid and bases are normally colorless solutions. So if you add acid to base or base to alkyl, maybe, then you are not going to observe anything. But if you are adding an indicator, then at a particular pH, the indicator will show you the result. And that's why you are able to know that, okay, the reaction is goes to completion. The theory which is based on this indicator mechanism is called Ostwald's theory. So Ostwald's theory of indicators are such weak acid or bases whose color are different from that of the indicator ion formed by their dissociation. So it is simple things. One is the change in color, and then color is accompanied by dissociation. So the mechanism is given. I'm not going more detail, but I want the pH. So if you want to know the pH of the indicator, then pH equal to log indicator minus IN minus by HIN. IN minus means after removal of H plus. The conjugate base is IN minus by HIN plus log PK plus PK plus PK. pH equal to log IN minus by HIN plus PK. Today, many students have not joined. What is the reason behind it? I don't know. Somnath, can you say? Or 5 are there? How many are there? No, all okay. All are present. 1, 2, 3, 4, 5, 6, 11, 12. Okay. Very good. Okay, next one is for indicator pH. So pH of an indicator is nothing but pH equal to pKw minus pKb plus log INOH by IN plus. So by doing this log INOH by IN plus, taking log of it, and pKw, pKb, you can able to calculate the pH of the indicator. Remember, different indicators have different pH value. Therefore, whenever you are selecting an indicator, you have to know which indicator I should use, depending on the which type of neutralization reaction you are going to proceed. Strong acid strong base के लिए अलग होगा, weak acid strong base के लिए अलग होगा. ये अलग अलग होगा. You have to remember which one you want to take it. Next. Their theory is also called modern quinoid theory. There we are not discussing it. Color change range of indicator. Okay, very interesting one here. You don't have to remember everything from table 8.3. Few things to remember, which are important indicator you have used in the lab during your +2 or +3 classes. Methyl orange pH ranges from 3.1 to 4.1. So pH ranges from 3.1 to 4.1. The solution of the solution is red, because you know why red. And also its alkali solution is also red. Different indicators are listed here. One is crystal red, metacrystal, methyl orange, ethyl orange, methyl red, methyl yellow. So many different indicators have different pH. Ranging, basing on this, you have to choose your reaction requires which indicator so as to find out the end point or neutralization point of an acid-base reaction. So the selection of indicator is very important. Otherwise, there will be no change in color, or the color remains as it is. So you will be unable to know when the reaction has come to the end, or when the neutralization occurs, you cannot say at all. It depends on the indicator. Without indicator, but remember, potassium permanganate oxalic acid redox titration does not require indicator because KMnO4 is a self indicator. So whenever any reaction, a self indicator is available, then no need to have an indicator. You can use that both because KMnO4 is colored. The next one is selection of indicator. Where I just have discussed it. Okay. If I will ask you a question, only strong acid or base is used as a titrant. Why? Why only strong acid or base is used a titrant? Why? Can you say or no?
Sir,
Okay.
because it will release more hydrogen ions or OH minus ions.
Then
The
what will
faster
happen? Okay, you are taking acid in the burette and alkali in the conical flask. Why you are using strong acid or strong base? Why not weak acid? Because as you know, weak acid gives less. Okay, you have told right thing, but important thing is a strong acid, strong base. They have equal number of H plus and OH minus ion. So neutralization occurs. But if you are using a strong acid and a weak base, then weak base produces less number of OH minus ion, but strong acid produces more number of H plus ion. There will be an imbalance of H plus ion. Some H plus ion will be remain, and hence the reaction is not called neutralization reaction. So reaction is said to be neutralized when the number of H plus ion is equal to number of OH minus ions. Okay. Okay, next we go to neutralized titration 2. A role of solvent in acid-base titration. Role of solvent. Remember, as I have told you, without a solvent, the acid-base titration does not occur. So you need water as a solvent. Normally we use water as a solvent, but not always. You can take different solvent like ammonia. You can take ethyl alcohol, also benzene. These are some solvents, but many reactions occur in aqueous medium. So water is called as the universal solvent. But except water also other solvents are there. Those are affecting the rate of a chemical reaction, or those are important for all of us. One that some solvents are ammonia, water, ethyl alcohol, and benzene. So these are the solvents. And if you see table number 9.1, then you can see acid 1 plus base 2, acid 2 plus base 1. Basing on your report. On your report, I am modifying it. This is simply the conjugate acid of base. Addition of H plus is conjugate acid. Addition of B plus is when a condition of subtraction of H plus is called conjugate base. I am telling you some of the reactions where indicators are used. That are for example, is solvent. If you are using isopropyl alcohol as a solvent, then here you use indicator phenol red. Means for different medium of solvent, means if you are doing a particular reaction, a particular medium, basing on the medium, the solvent, the indicator is different. Therefore, I'm telling you, if you are using a solvent of isopropyl alcohol or ethylene glycol or acetic acid, then remember you have to go to the indicator is phenol red, called phenol red. Similarly, if it is nitromethane or acetic anhydride as solvent, they are very weak bases. So you can use methyl violet as the indicator. So depending on the acid or base, the indicator varies. Then we go to solvent extraction or solvent systems. This is not so important. Okay. Then we go to importance of dielectric constant. So do you know what is called dielectric constant? Remember, for water is very high. Water can commonly dissolve many compounds because of its high value of dielectric constant. F1 F into Q1 Q2 by R square. F into Q1 Q2 by R square. The formula. Okay, then we go to applications of pH. pH condition are to be maintained in manufacturing process industry. For example, you are manufacturing clothes, you are manufacturing food or dry nuts or any food also. Then pH maintain is very important, because if you are not maintaining pH, then the food may spoil after some days. Therefore, you have to make it pH resistance, means pH will not change. Then only you can say that the reaction, that the particular product is useful. Therefore, in manufacturing industry, or you can, or example, you are preparing a new chemical or a new metal or new metal oxide, then also pH is very important. Without having a, if you change the pH, then there will be different product you get it. The next one is acid base titration is also used in certain analytical methods. The sort of application can be seen in the Geldal method for determination of nitrogen. You know, Lasaisen test, it is used to detect the presence of nitrogen or halogen, etc. in the organic compound. Similarly, nitrogen can also be measured or detected in organic compound by Geldal method. This Geldal method has also application of pH. Similarly, in pharmaceutical industry, as you know, that if you have seen many medicines in the pharmaceutical industry, they are preparing. You have seen some medicines which can last long, up to 5 years, 6 years, And you have also seen medicines which can only remain in a good quality or expiry is in between 3 to 4 months. That means these medicines are prepared basing on the pH value. So if you are adding a buffer solution to a medicine, then the medicine lasts long because it does not change its pH. So main problem is that if a medicine, if you want to keep it for few expiry date very long for a long period of time, then you have to add a buffer solution to it to make the pH resistance, means pH will not change. Therefore, the application of pH in pharmaceutical industry is very important. Okay. Uh, so many things I have discussed. So some now I'm requesting you to please um, look in this top two chapters. One more thing is, for example, a question will come like this. I'm reading a question that what is called as define the solvent to be amphiprotic. Amphiprotic, non-ionizable, and protic. Then what do you mean by amphiprotic solvent? Question may come, very simple thing. What do you mean by amphiprotic solvent? Then remember, these are possess both acidic and basic properties are called amphiprotic. So very simple questions will come. How can you differentiate non-aqueous solvent into amphiprotic or aprotic, basic but not acidic called non-ionizable solvent? So first of all, I'm explaining you what is amphiprotic. These such as water, ethanol, and methanol. Water, ethanol, and methanol, they both behave as amphiprotic. And these are ionizable also. Amphiprotic solvents undergo self-ionization or called autoprotolysis. Autoprotolysis. The next one is aprotic. These are neither acidic nor basic. The inert solvent sometimes we call benzene, toluene, petroleum ether. These are the benzene, toluene, petroleum ether, carbon tetrachloride. They are called aprotic solvents. Okay. Are you listening to me, students? Amphiprotic and aprotic solvents.
Yes, sir.
Yes.
Yes, sir.
The aprotic means neither acidic nor basic. Okay. These are benzene, toluene, petroleum jelly or petroleum ether like this. And one more is called uh, protophilic solvents. Means they are basic in character and react with acid to form solvated protons. So protophilic means they are basic in character. They are basic in character, and when you are dissolving, they react with acid to form solvated protons. And one more is protogenic solvents. Protogenic means they are acidic substances like sulfuric acid. They exert a leveling effect on bases. So protogenic means it is an acidic solvents are called protogenic solvents. And last one is non-ionizable, means ether, dioxane, ketone. These are non-ionizable because ether, You cannot ionize ether. You can ionize dioxane, pyridine. They are non-ionizable solvents, but basic, but not acidic. They are basic, but not acidic. And hence they are non-ionizable, also called non-ionizable. So these are some of the things I have discussed it. Anything? So 10 minutes left. So anything you want to ask me, you can ask. So we have covered many things in the last 2 hours duration. The important things are going. What is the rate of reaction? What the order of a first order reaction? What the order of a, how to calculate the rate of first order reaction or rate constant, derived rate constant of first order reaction and second order reaction, and then how to do the differential method or integration method, mean the process of kinetics to calculate the rate of a chemical reaction. Which factors influence the rate of a chemical reaction, like temperature? Then you have a concentration of the reactants, like this. Also, you can able to say. So these are the important things. Then we have discussed about pH of solution, acidic pH, basic pH, or basic acidic buffer, basic buffer, buffer solution, buffer capacity, pH of different mixture of solution like weak acid, strong acid, weak base, weak base, its pH. Also, we have discussed it. We have discussed about indicators, how indicators are important in acid-base titration or called neutralization reactions. Similarly, I've all discussed indicators of different types basing on their pH range. Indicators have been classified, and also you can use indicators basing on your need. So, like this.
Phenolphthalein is universal indicator.
Yes. Okay. Then also we have discussed about the importance of titration, and one more thing. Remember that acidity and basicity depends on dielectric constant of a solution. Then end point, how to know the end point of a titration. End point depends on the use of indicator. And remember, yes. Gitanjali, your microphone is on mute. Okay. So that much about your today's class. If you have any doubt, you can ask me.
Sir, I have one question. Sir, toluene is used for analytical chemistry for resist to change in water quality. For before analysis, for one example, we collect water sample for analysis. That time we
Mhm.
added toluene 3-4 drops.
Mhm.
What will be chemistry for that toluene? How to resist the change in properties of water?
You are telling about toluene, okay?
Yes, sir.
Toluene actually it is prepared from gasoline, okay?
Okay, sir.
And you know that it is mainly used to improve the octane rating, okay? You know octane number. Octane number
Yeah.
is, for example, you know that if you are using a petroleum in your bike or in your car, then there will be anti-knocking. Anti-knocking means it will not polluted and not create any more sound. Basing
Okay.
on this, that number has been assigned. So if you are adding toluene to gasoline, then it is improving your octane number, and therefore it is mainly used in automobile of high racing cars. You know racing cars are there.
Yes, sir.
Racing cars, that racing car you are using toluene as a solvent along with your petroleum. Clear? And this
Okay.
this
Thank you.
toluene is increasing the octane number, and this octane number means it will not produce any knocking. Knocking means not produce any sound.
Okay. Thank you, sir. Thank you, sir.
Okay. Any question? Anybody can ask the questions. See, I am trying to explain the basic things behind these units, because not possible to read out everything, because only 2 hours class and one block. It is only it is just simply to make you understand the chapters, the things which are there, and some basic concepts behind this unit. Gitanjali, if you are not interested in switch up, you have been mute up. Okay. Any question? Because 3 to 4 minutes left, then we will end this class. Okay, one. Somebody has asked a question regarding the universal indicator. So normally indicators normally used are methyl orange, methyl red, then phenolphthalein. These are called as the universal indicator, because they have a range from pH range from 4 to 10. 4 to 10. So in between this they are used. The universal indicator means the indicator which is used for various type of titrations, and one of them is your methyl red, which is called as the universal indicator. Any more question you can ask. Even pH, POH can be used in Henderson equation. Yes. POH can be used. No problem. pH and POH. If you add this, it becomes 14. So if you know pH, then you can calculate POH. If you know POH, you can calculate pH, because pH plus POH is equal to 14. Somebody has asked a question also. Called as the dielectric constant of water. See, water in its water may be acidic or basic, but if it is a neutral, then its dielectric constant is nearly about 78.78, like this, or 80. Normally it is called 80. Means the capacitance of a capacitor will be 80 times if water is used as dielectric constant instead of air. So water has dielectric constant of 80, nearly 80, 78 to 80. Any more question? If you can ask me. Or anything I can about the pH. Ojas has asked a question. pH control is done in petroleum industry also to remove sulfur compounds and to reduce the acidity of crude oil. Yes, it is true. Because see, if you are not controlling the pH, then there will be a problem, because the solution may be acidic or basic. You have to make the pH fix. Otherwise, the particular material you have prepared or particular solution you have prepared will be reactive. Therefore, you have to control pH always. pH control is important in everywhere, not only in petroleum industry, in any type of pharmaceutical industry, food industry. pH is to be maintained. pH is important. This is more pH everywhere. Because pH crude oil. What is crude oil actually? What is crude oil? Crude oil means one thing is important. What is crude oil? Crude oil means, for example, pH of the fresh oil is 10, and pH of crude oil is less than that. So when it falls below 9, then it is then the crude oil becomes a detergent oil. Means it is not used. So you can use only if the pH is nearly above 10. pH 9 to 11 is used. Normally, pH 9 to 11 is used. And remember one more thing, and that a pH measurement is required in petroleum industry to ensure that the separation process used in desalting is optimized, while also reducing the corrosion of wastewater. So corrosion ज़्यादा नहीं होगा, इसलिए भी pH को तो maintain करना है. Okay, so it's now time. Should we end the class today here? We should end the class because our time is there. So thank you very much. Thank you everybody for joining. And I have tried my best to explain you whatever possible in the limited period of time. And also we have very good interaction every day. In the last 10 minutes, I am interacting everybody and taking the questions also and answering it. So thank you very much, all of you, for joining this. Thank you. Yes, it also prevents scaling of the equipments. Yes, it is all right. Thank you very much. Thank you all. Thank you. Thank you. Yes, I am unable to share my email ID. So anyway, tomorrow immediately after start of the class, I will share my email ID. No issues. Thank you very much. Thank you. Mahendra, Somnath, Radhasmita, thank you all. Shibam, thank you.